Okay. In the last class, we learned how to do lifting analysis with DNV factors. Now, in this class, what we are going to learn is how to do a skew lifting analysis. Now, I explain what is skew. So, skew happens due to this fabrication tolerances when there is a sling is less loaded and one sling is more loaded. And there are two factors also generally used, 1.25 and 1.5. Now, let's say I am going to use the skew factor of 1.25. So, in the previous analysis, we considered a factor of 1.25. So, here we are going to do the analysis without applying skew factor as a blanket, but we are actually modeling the skew. So, now how to model the skew? Now, take a look at the boundary conditions what we provided. So, in the first analysis, what we did was that we created a fixed joint for the hook point. So, we give the fixity of 111. Now, if you want to apply the skew, we need to create one more joint. So, that joint, what we call it as sub vertically supported joint. So, here what happens is, first one we will keep it same. Second one, if you look at the fixity, there is a change in the fixity. So, for the Z, we will put it 0. That means that joint is free to move in Z. And now we will calculate what is that difference in load incoming. So, let's say if you are going for 1.5 is the factor, we will consider 75 and 25. So, that's 75%. We will apply it as a skew load, as an upward load over. Already there is a gravity load acting downward. So we will get if we apply 75% load as skew load over here, then what happens? We will get that extra 25% as free action in the fixed support. Now, what I am going to do right now is, like, I am assuming my weight COG and geometric COG is matching. So I don't have any change in the angle of these links between the horizontal. But if you have a change in the angle, the equation is not straightforward. You want to account for the angle as well. Okay, so here I am not going to account for the angle because my geometric COG and the actual weight COG is matching. So in our masterclass, we will be discussing about this angular reference as well. Now, when we do the skew, we need to do two times. One is one set of sling is taking more load, like 50 plus X%. So in our case, I am going to use the factor of 1.25. So one set of sling will be taking 62.5% and another set of sling will be taking 37.5%. Now in the second case, what we will be having reversed. So the first set will take 37.5 and the other set will take 62.5. So I want to actually model this one. So before modeling this, let's understand what are the changes in the factors. So the COG shift factor, dynamic amplification factor, weight contingency factor, and consequence factor, I am keeping it same. I am not going to change. The skew factor, since I am actually modeling the skew, it will become 1 over here. So now my total factor become 2.85. Okay, 2.85. So now I want to change my this one, the modeling. So what I will do, I will take the previous model. Let me save it as somewhere like, okay, skew factor, skew. Okay, so I will again take a look at the factor. So now my new factor is 2.85. So I want to bring the 2.85 over here. So for that I will come to load, combine. So LC1 I will keep it as 2.85. Sorry, 2.85. Now let's take a look at what is the final value. So LC1 combo display load summation. So it is 437 minus 437.78 acting downward. Okay, so what I can do is I can just paste it over here. Okay, So minus 437. So what I'm going to do is I will add two more cases. First one is SK1. SK1 is I will have a skew load of 62 point, sorry, I want to change it. I'm going for 62.5%. So 62.5, so 62.5% into this one, and the other one is 37.5. So you understand, right? 62.5 and 37.5, it is from this difference. So if my increase is so skew factor is 1.25, that increase in x is 12.5%. That means 50 plus x is 60, 50 plus 12.5, that is 62.5, and 50 minus 12.5 is 37.5. That's how I reach this value. Now I need to create a joint to apply this force. So the better way, there are two approaches people used to do is, so this is my joint hook point. So they will create a joint at the same location. So if I just put the HK, I'm not one, at the same location with a fixity 1 1 0 1 1 1. It's like coinciding. So if you apply this, follow this approach, it will be very hard for you to visualize as well. So what I would suggest is you can put a small increment. Maybe you can take it like 10 centimeter, so that maybe 10 centimeter is more, I think. Maybe you can go for 5 centimeter. Okay. So here, let me change the name of the joint. I'd like to have it as HK01. Okay. So now I will connect the diagonally opposite slings to hook point. So now let's take a look at the slings. So this is my pad 1, pad 2, pad 3, pad 4. What I'm going to do is I will connect pad 1 to HK01 and pad 3 to HK01. So for that, what I will do, I will put HK01, then pad 3 to HK01, HK01. Okay. So I connected this one. Now I want to have this load applied. So to see that, what I would do is, so you see the sign convention. The gravity load is acting downward, so you will be having a minus. But these two should be acting upward. Then only you will get that reaction. So for that, what I am going to do is I will apply that load SK0, SK1. So SK1, I will tell, okay, this is the case when, so I told you we need to do two cases. So first case is 62.5% acting on that one. So I will apply 273.61. That is one load case. Okay. So one load condition done. Now next one, I will put it as SK2. Here I'm going to apply 37.5%, and that value is 164.17 acting upward. Now I have two skew loads, so I want to define two different load cases. So for that, what I would do, I will come to load combination. So my LC2 will be a combination of LC1 and SK1. So that means LC1 will be acting downward and LC2 LC1 will be acting downward and SK1 will be acting upward. My LC3 will be a combination of LC1 and SK2. So now take a look at that summation rate. So if you look at the self weight, so that self weight is acting downward. You can see that is like minus 153. SK1 acting upward, SK2 acting upward. Now if you look at the load combination LC1, the total summation, it is acting downward, right? Minus 437. Now if you take the LC2, that is a combination of this minus 437 acting downward and this 273 acting upward. So what you should get is a reaction at the hook joint of that remaining person. So if you look over here, you will get 164. So 164 is actually equal to SK2. So again, I want to make something clear with you, so people get confused at this point. So let's say LC1 is a summation. So you have that value. So it is like self into whatever factor we provide. So what we provide is 2.85. Sorry, self into 2.85. So I'll just put it over here like self into 2.85. Now LC2, so this value is my 437. Now LC2 is LC1 plus SK1. So what will be the resultant value? It will be this one plus this one. So which is actually equal to SK2. Now LC3, that is my second skew case, is equal to LC1 plus SK2. So here what you get the reaction is plus this one. So it should be equal to minus 273. Now if you look, see, the first one is equal to the negative sign of SK2 and LC3 is equal to the negative sign of SK1. So now our load combination, everything is correct. So what I can do is I just want to make one thing clear. So regarding option, I can bring these things back. I just want to put the skew case, but otherwise you will see undesirable result. You want to see only the skew case load combinations. So click apply, close. Okay. So I will save this file. Let me close this file before running. And here I need to have change my folder, and I will check my skew. Maybe I can update my folder. Then I will go to data chain just to check the load case selection, because I am not fully confident. Okay, this one load case selection is correct. Now I can change my naming and I can run my analysis. Okay, so I keep the same setting, static analysis with gap elements, and my element check option is also clear. Now if I take this one, so I can check for my member uses. So there is a high chance the member uses will have been increased. Okay, so okay, so here the member uses were less at the earlier stage. Now it got increased, and it's showing some sling UC and the pada UC. Now let's see the actual behavior, how this one behaves. So actual deflection behavior of a skew case is something like this. See, this is the actual deflection behavior of skew case. So this is with the 62.5% load acting upward. Now with that 37.5% load acting upward, this is the skew behavior. So the behavior is correct. If you have a bigger structure, you should have a saddle type of deflection behavior. Now you can look at the load cases. You can look it separately. So how this one is changing. Now if I go for member UC, okay, I can deactivate this thing so that I can see the result clearly. See, you can see the slings which we are taking 62.5% is having more UC. That means it is getting more load, and the other one is less load. and you can see the UCs accordingly. So this diagonal is taking more UC. So you can see over like 0.51. So it's, and this diagonal is taking less UC because the load is all coming in the other one. Now if you want to look at the sling maximum axial internal load or tension internal load. Okay, see, these two slings are taking more load and the other one is taking less load, and this will be reversed in the other case. So if I go for LC3, see, it is straightly reversed, and it's the same with the tension as well. Or remember, where is it? Maximum combined UC. See, now the other diagonal is taking more UC than the first one. So this is how you do a skew analysis. So then the rest of the things is you check for the joint reactions. So I can check for the joint reaction. So joint reactions, sorry, I'll go to table. So you can check both. So you can see the hook point is having LC2, like what we had. The reaction will be like a negative sign of the gravity. So 164 and 273. This one doesn't have any reaction. So that means there is no lateral reaction as well. So if you want to have the joint spring forces, if you want to see the forces, you can click over here. So there was, see, spring forces is very less. So see, this is very less forces. So our reaction is stable, and this is how you do a skew lifting analysis. Okay, in the next class, we will discuss how to actually model a COG shift and do the analysis.